From the very first spark of life, DHA is working overtime, building brains and tiny eyes, fueling dreams that start inside.
Welcome to The Good Oil, the podcast that explores the science behind DHA and its importance for health. I'm your host, Bassam Hallak, and today we're joined by Professor Barbara Meyer, a leading expert in DHA and its role in pregnancy. Dr. Meyer has conducted pivotal research that has helped deepen our understanding of how DHA affects maternal and fetal health. Today, we'll be discussing the crucial differences between healthy pregnancies and complicated pregnancies, such as pre-eclampsia and intrauterine, I hope I'm pronouncing that right, Barbara, growth restrictions, IUGR, and how DHA may play a key role in both. Barbara, thank you for joining me again.
Thank you so much for having me, and it's a pleasure to be here to discuss such an important topic. DHA is so crucial in pregnancy, especially when it comes to complicated pregnancies like preeclampsia and intrauterine growth restriction, but I'll refer to that as IUGR because it is difficult to say.
Thank you for
And
helping me for that.
yeah, that's okay. And I'm really excited to share my findings today.
Excellent. We're really excited to have you on the show for obvious reasons, especially around the role that DHA plays in pregnancy. To begin with, can you briefly explain what DHA? I think we talked about that in our first episode, but why is it important for pregnant women, especially when it comes to complications like preeclampsia or IUGR?
DHA, or docosahexaenoic acid, is an omega-3 fatty acid that is crucial for brain development and eyesight development. And during pregnancy, DHA supports fetal brain development, especially during the early stages of pregnancy, but also later in pregnancy, the second and last trimester of pregnancy. So, DHA is important for cardiovascular health, it reduces inflammation, and it supports the nervous system. So, what makes DHA even more significant in complicated pregnancies like preeclampsia and IUGR is its role in the maternal fetal health axis. So, essentially, how well the body can provide the nutrients needed for fetal development. In complicated pregnancies, there are often issues with nutrient transport or inflammation, which is why DHA can help address these challenges.
And I'm assuming that there's been some connection between low DHA and preterm births, or is that still a study that's still ongoing?
While we do know that DHA supplementation during pregnancy, on average, after combining all the studies that have been conducted, it prolongs gestation by 2 days.
Oh, wow.
Now, you might not think that 2 days is a lot when pregnancy takes 9 months. But when it's going to be a preterm delivery, 2 days could mean the difference between life and death for the baby that's being born.
Yeah.
So DHA, on average, prolongs pregnancy by 2 days.
That's great insights. Let's dive into the studies you've conducted. One of your studies, titled Longitudinal Assessment of Erythrocyte Fatty Acid Composition Throughout the Pregnancy and Postpartum, looked at how fatty acids, including DHA, change through healthy pregnancy. Can you share what you found and why is it relevant to understand pregnancy complications?
Yes, so this study followed women throughout pregnancy and into the postpartum period or after pregnancy. And we measured their total fatty acid profiles, including DHA.
Mhm.
And we measured the DHA in red blood cells because red blood cells is indicative of what the maternal body stores are of DHA. And we found that DHA naturally fluctuates during pregnancy and that it increases during pregnancy, and then post-pregnancy it reduces back to pre-pregnancy levels. So the levels do go up during pregnancy. However, in pregnancies where complications like preeclampsia or IUGR develop, we observed that maternal DHA levels were lower in the third trimester of pregnancy compared to healthy pregnancy. So, when DHA levels are suboptimal, there may be an increased risk for complications such as poor fetal growth, preterm birth, or issues with maternal blood pressure regulation, for example.
That's really fascinating insight. Now, regarding to preeclampsia, your research also discussed how preeclampsia is associated with comprised maternal synthesis of long-chain polyunsaturated fatty acids like DHA, which leads to offspring deficiencies. right? Can you explain this a bit more?
Absolutely. Pre-eclampsia is a pregnancy complication characterized by high blood pressure, proteinuria, which means protein in the urine, which is indicative of damage to the kidneys, as well as inflammation. One of the key factors in preeclampsia is vascular dysfunction, so which affects the flow of nutrients and oxygen to the growing fetus. So our study, preeclampsia is associated with compromised maternal synthesis of long-chain fatty acids, revealed that women with preeclampsia have the reduced ability to synthesize DHA. Now, normal, healthy pregnant women are able to synthesize the DHA that's required for the fetus. So this means that not only are they not getting enough DHA, but the body's ability to produce it from other fatty acids is also impaired. Now, what's concerning is that this deficiency directly impacts the growing fetus, as they too have lower levels of DHA, as well as other polyunsaturated fatty acids. So all the polyunsaturated fatty acids are lower in the fetus. And lower DHA levels are linked to poor fetal brain development, also an increased risk for preterm birth, and even potentially long-term detrimental challenges for the child.
That's really alarming, actually. When you say that the mother's actually synthesizing its own DHA, I'm assuming it's important to have the right diet to be able to do that. Is that correct?
Yes, so women can synthesize DHA from another omega-3 fatty acid called alpha-linolenic acid, and a lot of people refer to that as the plant source of omega-3. So it's rich in green leafy vegetables plus nuts like walnuts and so
Yeah.
forth.
Hmm.
So women can synthesize DHA from alpha-linolenic acid. But in complicated pregnancies, the women have less ability to synthesize the DHA from these plant sources.
That's very interesting. So, in light of your research, what advice would you give to pregnant women, particularly those with a history of pregnancy complications or risk factors for pre-eclampsia?
Well, my advice is simple: maintain optimal DHA levels before and throughout pregnancy. So, given the strong links between DHA deficiency and pregnancy complications like preeclampsia and IUGR, it's crucial to ensure DHA intake is adequate from the start, even before pregnancy. So, for women with risk factors, such as a history of preeclampsia or high blood pressure, early DHA supplementation may be particularly beneficial to increase maternal DHA levels. The science on the effect of DHA supplementation to prevent preeclampsia is still controversial. That means that some studies have shown a benefit, while other studies have shown no benefit at all. So the jury's still out in terms
Mm.
of does DHA supplementation prevent the development of preeclampsia. So, nevertheless, monitoring DHA levels throughout taking regular blood tests could be an effective way to assess if supplementation or dietary adjustments are needed. So, some women just don't like fish or seafood, and that's the richer source of DHA, and therefore supplementation would be suggested. Pregnant women should work closely with their healthcare providers to make sure they're getting enough DHA either through their diet or supplementation, depending on their individual needs.
That's really great advice, especially for women who plan to have babies and also while they're pregnant. How does DHA impact fetal growth, and why is it particularly important in pregnancies with IUGR?
IUGR occurs when a fetus doesn't grow at the expected rate during pregnancy. So the definition of IUGR is on the lower than fifth percentile of the growth curve, meaning they're at the bottom end of
Yeah.
the growth. And that's really due to poor placental blood flow and nutrient transfer. It's as though the mother doesn't realize she's pregnant and she's trying to feed this growing baby, but they're just not transferring the nutrients, including DHA, across. So, in that situation, low maternal DHA status may lead to the placenta's functional inadequacy and, accordingly, their fetoplacental growth and development. So, therefore, DHA plays a key role in maintaining a healthy placenta, which in turn ensures that the fetus gets the nutrients it needs to grow. So, in pregnancies with IUGR, we often see lower DHA levels in both the mother and the fetus. And this can worsen the condition by impairing fetal development. So, DHA is necessary for all cell membrane structure. Every cell in our body contains DHA. It's not just the brain, but it's every cell. And it also has an effect on inflammation, which helps maintain the placental function and support fetal growth. So, therefore, DHA supplementation may help improve placental efficiency and reduce the risks associated with IUGR, especially if it's introduced early enough in the pregnancy. But we need the research studies to definitively show that DHA supplementation will reduce IUGR. We don't know that it will, so we still need some more research in this area.
So DHA is really essential for both healthy placental function and fetal growth, particularly in the face of complications like IUGR. Are there any other aspects of pregnancy complications where DHA can make a difference or could make a difference?
Yes, certainly. DHA does have broad implications, especially in terms of reducing inflammation. So, in complicated pregnancies, inflammation is often playing a key role here, and DHA is known for its anti inflammatory properties. So, by reducing inflammation, DHA may help reduce the risk of preterm labour, hypertension, and potentially other complications.
So that's an important point. So, DHA isn't just about fetal health, it's also about supporting the mother's overall health, which is well documented. As we wrap up, Barbara, what final thoughts do you have for expecting mothers who want to ensure they are supporting their health and their baby's health throughout the pregnancy through DHA?
My final thoughts would be to prioritise DHA from the beginning, even before conception, if possible. Now, DHA is vital for both the mother's health and the development of the baby's brain and eyes and the whole nervous system. So, in pregnancies at risk for complications, maintaining optimal DHA levels may possibly make a real difference in maintaining maternal DHA levels. So, DHA is really important in pregnancy, but also in complicated pregnancies. So, my advice would be talk to your health provider about your DHA level, and supplementation may be important, especially if you're at risk for developing complication. And DHA is one of the most important nutrients for both maternal and fetal health during pregnancy.
Thank you, Barbara, for such an insightful discussion today. We really appreciate you sharing your research and expertise with us today, and also to share some insights to expecting or aspiring mothers who want to have children in the future.
Well, thanks for having me, and it was been a pleasure to talk to you about DHA's critical role during pregnancy and how we can all work together for better outcomes for both mothers and babies.
Thanks, Barbara. And to our listeners, thank you for tuning into The Good Oil. Don't forget to subscribe for more episodes exploring the science behind DHA and its importance for health. Until next time, take care and stay healthy.